that's why we were able to communicate over this tunnel and get all those services which are over there.
Okay.
Using the private IP address. So you got the point where you need to use this one. I mean, especially right now, if you have field offices, 1 computer, 2 computer, 3 computer, GRE tunnel, and he's able to join to domain, he's able to get an IP address to the DCP, everything.
Okay.
Everything is possible. And also in some cases, people was used because you have your firewall in your office, right? You have everything in your office, so you want even the client, if they want to go to internet, they should come through the GRE, bypass these firewall rules, and then go to the internet. Not directly have a default route and go to internet, whatever he wants to access. So you want him to come to the office network, and from here they should go to the internet and then go back to the request. So that's how most of the use cases of the use scenario of these technologies are. Clear, right?
Yeah.
So GRE, and then if you want to encrypt it, just to be on the safe side, because it's going over the untrusted network or public network. So you want to make sure that the traffic can, for example, this client, if he's accessing Active Directory, DHCP, any other services,
it should be
secure. Then you apply IPsec on the top of the GRE tunnel. So that will make it GRE over IPsec.
Okay.
The last configuration that we did, there is for GRE, I told you it's using port number 500, UDP port number 500, and 4500 for NAT detection, right?
Yeah.
If there is a NAT involved, the GRE header, you will see exactly when it was there for 500, right? It will change to 4500 because it will take the insider IP addresses and put the other one so that it knows by default. You don't have to do anything. It knows that there is a NAT involved, so that's why if there is an data integrity issue, so they take into consideration that, okay, let's not do this one, add another layer and name it 4500 port, and then they are able to establish the tunnel. And the port numbers, you have to know them, because if there is a firewall involved, you need to allow those ports. Okay?
Gotcha. Yeah.
So now, the other use of the other flavor of the VPN is DMVPN, Dynamic Multiple VPN, okay? So now, there is also GRE, we studied, there is also MGRE, okay? MGRE stands for GRE Multicast, or GRE Multiple GRE. So what's the reason? Now, if you want this one to have a tunnel, right?
Okay.
This one we already had a tunnel, correct? So this is point-to-point tunnel. If this one wants to have a tunnel to this one, you have to create another tunnel. So that means you need to come, set an interface, here also another interface, IP address, everything. So it will be a separate point-to-point network.
Okay.
If this guy wants to talk directly to that office, so you need to create another tunnel over here, right?
Nice.
So this is point-to-point tunnel that will be created. So what they come also here, that instead of using, and this will be different subnets, right? We use there 12.12.12.0 there, right? Okay. So here you will use maybe 13, here you will use 14. So different subnets are now involved, right? And the number of router or the size increases, the number of the VPN connection also increases. You have to go, this one has to go create a tunnel here, this one also has to go and create a tunnel here, this one also has to go create a tunnel here. So all the way the number of tunnels will increase, right? Okay. That's the point. So they came up with a solution. They are saying you can create hub and spoke topology, right? Till now what we did was spoke to spoke, right? So hub and spoke, you also remember maybe from your previous lessons, there is one router that will be configured as a hub,
Yeah.
right? That's normally your HQ office, correct? And the rest will be configured as a client. So that is
Anyone who wants to go to client should go to hub. Then
yes. So and also the number of the tunnels will also decrease, correct?
Yeah.
So now this guy, that if he wants to communicate to this side, he doesn't have to have a direct tunnel.
He should go to hub.
He already have a tunnel to your hub, and hub knows how to reach there.
Exactly.
Right? So if he wants to send to here, if you don't have spoke-to-spoke tunnel, then he has to go to hub, and hub has to come here, and this is how it will communicate. There is, always there's pros and cons to these topologies, but this is the way, this is how it's designed, this is how it's used, correct?
Yeah, okay.
So